Okay, we can start. This is near from the ByteDance. So it's great. It's my happy to be here. I like to deliver some this section to you. So actually, this section is Uefipayload on the Linuxboot. It's from the Lenovo team, the GuangYao. But unfortunately, he cannot be here for this event, so I deliver for him. Yeah. So here's the agenda. So we have three sessions. The first one is why we need the UEFI payload on Linuxboot. The second part is the current status and the solution update. The last one is the futures play. Sorry. So let's move to the first one. Why UEFI payload? The left this picture is about the whole firmware stack. Yeah, previous session the Liansen has showed it before. So we separate the firmware in three parts. Silicon code, bootloader is covered at platform level, and then the OS level. So in current firmware ecosystem, so mostly use the Tiano and the UEFI as the firmware solutions. So in our open system firmware community, we are trying to figure out the second firmware solution we call it cloud firmware. Cloud firmware use the coreboot and coreboot as a bootloader and Linuxboot as an OS loader to support Linux OS loader. I'm sorry. And then, but on this solution currently we cannot support the Windows boot because Windows OS is still is dependent on the UEFI interface. Another one is as this link here we put some OS operation system marketing data. So right now, Windows OS is still taking the 25% of the marketing. So Windows OS is still in high demanding, and Windows OS is still can boot from the UEFI only. Then we need to figure out the one solution for Windows OS to boot. And another one is UEFI have been deployed over maybe 20 years, more than 20 years. So right now, on the Linux environment, there is still no the UEFI stack. So we're trying to figure out the escape. Here is why we put on UEFI payload solutions on bootloader or OS loader, and why we choose this one on the OS loader. Yeah. Here, the first one, as we said in previous page, we need the UEFI interface for the Windows, right? Here are the two solutions. The first one is we put the UEFI payload on the OS loader. So we create the UEFI payload on the OS loader. Then we can enable it to put in the Windows OS. The second solution is we can put into the from bootloader, maybe coreboot or maybe coreboot, then put into the OS. For the solution 2, so their demo in the last year from Intel, they have put from the coreboot universal payload put from the coreboot to the Windows in the real platforms. Another information in last week in the OSFC, so I can see Elements kind of company has developed another solution. So it's another light UEFI payload on the coreboot, but we have not tested that. Yeah. So, but as we know, we have already production cloud firmware, just the coreboot Linuxboot solutions. So we have lots of the feature developed in the Linuxboot, such as a boot policy kind of things. So we would like to leverage these features in the OS load. So and with a final evaluate, we choose the UEFI payload on the OS load. Yeah. So anyway, these two solutions are both of these solutions are still on development process. Yeah. So then we will talk about the solution origin. So the original idea is start from Google. There you can search for the internet. The basic concept is use in the uroot they just load the UEFI payload in the uroot, create the UEFI interface, and then load the P image by the Linux kexit command. They can put into the Windows. This solution can put into the QEMU. This is the solution origin. The current state is here is our solution. So if with the Windows OS request, so we maybe boot based on the OS loader, then UEFI payload, then Windows. If boot from Linux, yeah, then go to the OS loader, Linuxboot, and then go to kexist to the Linux. So right now, we can support the install and boot the Windows Server 2022. We can support the boot policy logic, IPMI, refetch kind of boot policy through the root. But this policy is from the IPM, from the autoban, for the autoban setting. We also can support the object ROM loading to enable some device such as the RAID, NIC card kind of things to boot. And also we can support in the UEFI payload, we can also support the PXE, HTTP, or hardy boot. Yeah, that's the current status. So what I have done on this solution, and let me share a little bit more. So we have improved a little bit something based on this solution. The first one is before they just create some memory map, SPI, or some BIOS kind of interface based on in a Linuxboot. Right now, we get these tables directly from the coreboot, from the real system. The second part is we put the boot policy parameters into from the Linuxboot. Then all the boot policy, the whole system should be aligned. The last one is because after the Linuxboot, they will change lots of the interrupt settings or MSRs. So in current solutions, we have restored UEFI these settings in UEFI payload, and then the Windows can boot successfully. That's current status. Yeah. So future play. So we have talked about these ideas and status in the community for a few times. So we would like to upstream and for collaboration. Yeah, we like to contribute. So another one is next plan is we trying to bug fix and production incoming cloud firmware projects as plan. Okay, here is a contract. I'll go very fast. Sorry. Here is contract. So you can contract GuangYao or me from these emails. So and we looking forward to more collaboration on the UEFI payload in the open system firmware community. You can visit this wiki or join the open system firmware community for more discussion. Yeah. Thank you. Any questions? So I think that's all for me. Yeah. Thank you. Any question? Oh. Okay.
Does this? Yeah. Can you go back to the slide with the UEFI payload or something? What was it? I just wondered what it is. There was a slide with showing that one. What is UEFI payload?
UEFI payload is just create UEFI stack interface. UEFI payload. Just right now, let me introduce a little bit. Right now in our solution, we use the Linuxboot, put the Linux kernel, right? So we use the Linuxboot, use the kexist, the boot to another hardy OS. So if we put it in Windows, there is no UEFI interface. So UEFI payload is we create one UEFI stack, yeah, in this environment.
Sorry, which project is that? Where's the code for that? The UEFI payload. What is it?
UEFI payload is we just enable the UEFI stack on the Linuxboot. Yeah.
Sorry.
Sorry. Yeah. Oh yeah, UEFI payload. Yeah, great question. Sorry, I have missed explain something about UEFI payload. I think it's from this link. From this link, yes. So there in EDK2, is open source, right? In EDK2 report, so there is one package we call UEFI payload. Yeah. So we just this payload can be enabled from different from different environments. So yeah, we're trying to put this enable this one in a different, create the UEFI stack in a different environment. Yeah. Thank you. distribution on this Linuxboot stream. Yeah. Yes. Okay. Thank you. That's all for me. Thank you very much.